Confidence intervals for one population proportion. Population proportion and sample proportion. Consider a population in which each member either has or does not have a specified attribute. Then we use the following notation and terminology. Population proportion P, the proportion, percentage, of the entire population that has the specified attribute. Sample proportion P hat, the proportion, percentage, of a sample from the population that has the specified attribute. Sample proportion. A sample proportion, P hat, is computed by the formula P hat equals X divided by N, where X denotes the number of members in the sample that have the specified attribute and N denotes the sample size. Example: determine the population proportion P hat. The number of successes and the sample size are given for a simple random sample from a population, X equals 13 and N equals 16. To find P hat, we want to divide X by N. 13 divided by 16 equals 0.813. The sampling distribution of the sample proportion. For sample of size N, the mean of P hat equals the population proportion U sub P hat equals P, i.e., the sample proportion is an unbiased estimator of the population proportion. The standard deviation of P hat equals the square root of the product of the population proportion and 1 minus the population proportion divided by the sample size. Sigma sub P hat equals the square root of P parentheses 1 minus P divided by N, and P hat is approximately normally distributed for large N. One proportion z-interval procedure. Purpose: to find a confidence interval for a population proportion P. Assumptions: 1. Simple random sample. 2. The number of successes X and the number of failures N minus X are both 5 or greater. One proportion z-interval procedure. Step 1. For a confidence level of 1 minus alpha, use the standard normal distribution to find z sub alpha divided by 2. Step 2. The confidence interval for P is from P hat minus z sub alpha divided by 2 times the square root of P hat times 1 minus P hat divided by N to P hat plus z sub alpha divided by 2 times the square root of P hat parentheses 1 minus P hat divided by N, where z sub alpha divided by 2 is found in step 1 and N is the sample size and P hat equals X divided by N is the sample proportion. Step 3. Interpret the confidence interval. Example: given are the number of successes and sample size for a sample from a population. X equals 6, N equals 40, 98% level. Determine the sample proportion. First, we want to find P hat. P hat equals X divided by N. Substituting 6 divided by 40, which is 0.15. Continuing, decide whether using the one proportion z-interval procedure is appropriate. First, we want to know, is X greater than 5? Since X is equal to 6, yes. Next, is N minus X greater than 5? 40 minus 6 is 34, yes. The procedure is appropriate because the necessary conditions are satisfied. Continuing, use the one proportion z-interval procedure to find the confidence interval at the specified confidence level. First, we need z sub alpha divided by 2. Since the level is 98%, alpha would be 2%. Z sub 0.02 divided by 2 is z sub 0.01. Going to our table, we need to find the z-score for z sub 0.01, which is 2.326. So z sub alpha divided by 2 equals 2.326. Going to our formula, p hat plus or minus z sub alpha divided by 2 times the square root of p hat parentheses 1 minus p hat divided by n. Substituting, we have 0.15 plus or minus 2.326 times the square root of 0.15 open parenthesis 1 minus 0.15 close parenthesis divided by 40. Going to our calculator, first we want to find the margin of error E, which is everything behind the plus or minus symbol. 2.326, second, square root, 0.15, open parenthesis, 1 minus 0.15, close parenthesis, divided by 40, enter, and I get 0.1313. Rounding to 3 decimal places, I have 0.15 plus or minus 0.131. 0.15 minus 0.131 is 0.019. 0.15 plus 131 is 0.281. The 98% confidence interval is from 0.019 to 0.281. Margin of error for the estimate of P. The margin of error for the estimate of P is E equals z sub alpha divided by 2 times the square root of p hat times 1 minus p hat divided by n. Example: a poll found that 55% of a random sample of 1,094 adults said that they believe in ghosts. Determine the margin of error for a 99% confidence interval. Our formula is E equals z sub alpha divided by 2 times the square root of p hat times 1 minus p hat divided by n. Looking at our original problem, we know p hat is 0.55, n is 1,094. We now have to find z sub alpha divided by 2. Since our confidence interval is 99%, 100% minus 99% is 1%. Z sub 0.01 divided by 2 gives us z sub 0.005. Going to our table, z of 0.005 is 2.576. So now we have all of the information to find E. E equals z sub alpha divided by 2 times the square root of p hat times 1 minus p hat divided by n. Substituting, 2.576 times the square root of 0.55 parentheses 1 minus 0.55 divided by 1,094. Calculating, I have 2.576 second square root 0.55 parenthesis 1 minus 0.55 close parenthesis divided by 1 0.094. And I can arrow right or close my parenthesis, enter. Rounding to 3 decimal places, 0.039. To find the confidence interval, it's p hat plus or minus the margin of error, e. The 99% confidence interval is 0.55 plus or minus 0.039. To recap the section, confidence intervals for one population proportion. Population proportion and sample proportion. Population proportion is p and the sample proportion is p hat. Both are percentages. The sampling distribution of the sample proportion. The mean of p hat equals the population proportion, mu sub p hat equals p. Sigma sub p hat equals the square root of p parentheses 1 minus p divided by n.